Hey guys, David here and welcome to another Dark Art Guitars video. Today we're talking about the spindle of my brand new CNC machine here, and it is finally time. We have made the first chips on this machine. It is actually cutting stuff, and in this video I'm going to talk all about the spindle, how I come to choose this one, the install process, and of course what it can do and its performance. Now this right here is the Spinogy X22 2kW spindle in the automatic tool changer version with the SK20 tool holders, and it is the air-cooled version. Now that's quite a mouthful, but that's for a good reason, because Spinogy, which is a brand from Germany, they have a whole range of different spindles, and it's kind of super modular and you can get all the features you need without having to pay for any that you don't need. But let's back up a little bit here before we get into the weeds of it. When I was planning for this machine, one thing I knew was the spindle had to have automatic tool changing capability. That was one of the main driving points for the design of this machine. I've been wanting an automatic tool changer ever since I first saw one on the video, and definitely ever since I built my first CNC and realized how painful it is to manually change tools. This is finally my dream come true, an automatic tool changer, and it works great. Now, after coming to the realization that I wanted an automatic tool changer, I looked at the prices for those and quickly thought, well, maybe at a later point. And the prices have not gone down much, but I actually found some very reasonably priced options from China on AliExpress, and apparently you can get quite good results with those. If you're careful where you buy from, make sure that you verify everything, and then you can have some really good results in the just bit north of $1,000 for an automatic tool changer spindle, which is really good. However, I decided to go a slightly different route. Now, I first heard about Spinogy on Marco Rep's channel, who's an electronics nerd here on YouTube from Germany, and he also has his own CNC machine that he built, and he partnered up with Spinogy for his spindle. And I was super impressed when I saw that and went to the website and was like, that's surprisingly affordable for a made in Germany super high quality spindle. Now don't get me wrong, this is not cheap by any means, but non-ADC spindle, so just with a standard ER college down here, 2 kilowatts, you can get for around $1,000, which is actually really affordable for a made in Germany, super high quality with low run out and good specifications, reports, support, warranty, all of that. Now you can get one for a lot less than that on AliExpress, but you don't get any of the things I just listed. But once you get into the ATC realm, the prices do go up a bit, and also the accessories that you need add up quite a bit. So I knew that I was not able to afford one of these spindles. So I just kind of reached out to Spinogy just for fun, not really expecting a response, but not just did they get back to me. We hopped on a call, and a little bit later we struck a deal. Now, they didn't quite send me the spindle for free. My channel is not big enough to get totally was around 7,000 euros for the spindle and all of the accessories. But they did cut me a hefty discount, which I'm really grateful for. So make sure to go check them out, the link below, and support them, supporting fellow creators like me. Now the spindle itself is actually not that much. It's around 4,000 euros for an ATC spindle. However, that's just the spindle. In addition to the spindle, well, for one, you need all the tool holders. Without a tool holder, an ATC spindle is completely useless. And just one tool holder is also kind of useless by having ATC if you have just one. So I ended up with 10 of them, and at a cost of over 200 euros each. That's a hefty sum. Now we did consider going the China route for the tool holders, just getting the pull starts from Spinogy so that it matches up. And then, these are SK20. I think the taper should be the same as an ISO 20, which is a lot more popular. And just getting the pull studs is fairly cheap, and then you can get an ISO 20 tool holder for around $50 on AliExpress. However, after some deliberations and thanks to both them offering me a discount on the whole package, I decided to stick with the name brand Spinogy tool holders. And these also come with RegoFix ER collets. And if you have not heard of RegoFix, They are like S tier in terms of tool holding manufacturers, people that run currents that are like over $500,000, they use RigoFix. So using RigoFix collets on a hobby wood router, definitely a bit overkill, but that's what they suggest, and they are definitely beautiful. Looking at these RigoFix collets next to the Chinese ones, it's like night and day difference. Now, one single RigoFix collet also costs the same as a complete set of Chinese ones, but you get what you pay for. But enough about money. Let's talk about actually installing the spindle. You can configure it in all kinds of different ways. Just the basic configuration comes with a simple temperature sensor inside for the motor windings. As well, if you're going for the ATC version, it of course has some sensors to know whether the drawbar is pulled up or if it's down, and whether there's a tool installed, just to make sure that you can implement your tool changer logic correctly. But you can add all kinds of extra sensors, like you can add sensors for the bearings in here as well, just to give you even more temperature readouts. Now, you can also get all kinds of different electrical specifications. Now, standard is just a 2-pole motor at 2 kilowatts, or you can get up to 3 kilowatts in the same form factor as well. However, I decided to go with the 4-pole motor option, which just gives you a bit more torque, actually gives you twice as much torque, which is especially relevant at like kind of lower speeds. Now, I'm not doing a whole lot of that, but the upgrade from 2 to 4 poles is not that much more, so I decided to go for that. This not go for the 3 kilowatt spindle option, mainly because I don't think I actually need it for what I'm doing. I'm cutting mainly wood, and also at some point just power is getting an issue. Summing up all the different things that need power here and knowing what my breakers are, I'm already cutting it close, so a 3 kilowatt spindle was just a bit too much. Then to control the spindle, they also supply you with VFD, and that is just fairly standard spindle VFD. It's from Omron, but it looks basically the same as the Chinese ones you get, probably by higher quality, but it feels very familiar. And since you're dealing with a name brand German company, you also get recommended things like a line filter, which is always good practice to make sure that the power is clean and you don't create any dirty power. That's always a good thing. And you really know that you're talking to Germans when you get these kind of specialized cables here, and the cable that connects from your spindle to the controller is like €150 part, and I think that's mainly because they're using a very specialized connector here. Now, it is a nice connector, and you can just get the connector and trip it yourself, but I can see why they do not recommend that. It's a really complicated connector. But what I don't see is why they couldn't just use a more standard, simpler connector and either offer cheaper cables or allow you to more easily make them yourself. But anyhow, in for a penny, in for a pound. So I got their fancy cables and routed it all back. And these cables are very nice. They are all pre-crimped, and they feature not just a single ground per cable, but 2 ground connections, so to make sure that everything is super safe and properly grounded. In addition to the motor and sensor cables, you also need some pneumatics for the automatic tool changer version here. There are 3 pneumatic ports here. One is the kind of tool eject drawbar. That's where you put pressure to be able to unload the tool. Then there's a second port that is kind of air blast coming out of the cone that is active when you took out the tool, and it's going to the next one. There might be some dust on the tool, so that makes sure that all the dust is blown off and the taper is clean where it makes contact. And then the third one kind of puts pressure the different way and really locks in the drawbar, and that is needed after the tool change is complete. Now, they do offer a complete package for the pneumatics, as well as actually the electronics. I got just the VFD by itself, but you can get a complete electronics box that is pre-wired that you can just interface with your controller. And same for the pneumatics, but for the pneumatics I decided to just completely DIY it, as I figured I could save some money there. And the solution is very nice. It's using Festo brand solenoids, and it's nicely wired. However, I was able to find some used Festo equipment for like $10 a solenoid. They're new like $200. So I'm using that and have basically the same setup as they are using in the X22 which is their pneumatics control box. So the way it is wired is that you need a compressor with at least 6 bar. So mine is like, I think, between 6 and 8 bars, depending on how fully it is charged. And then that always supplies pressure to the kind of drawbar return. Now that doesn't always need pressure, but that's just the easiest way to automate that. And then when you want to eject the tool, the solenoid switches and vents that port and adds air both to the one that ejects the tool as well as a second airline to the cone blast, which needs to have its pressure regulated down just so you're not blowing out 6 bars out of the gentle mechanics in there. So that is regulated down to 1 bar. So I just need a single solenoid to switch all of these, and then it is wired in a way that if there's no power, it just locks the tool and nothing bad can happen. Now I also did wire up a second solenoid, and that will be for a kind of minimal quantity coolant or just air blast. I have it wired here, that's why there's this extra hose just dangling around, but I haven't actually implemented it, but that will come in a future part. On the electrical side, they provide you with some instructions of how to wire up the spindle to the VFD, of course, and how to configure that. What they do not provide very detailed instructions about is how to control the VFD. Now that, of course, depends on what kind of controller you're using. So I'm using the Masso, and while you would think that it is quite simple to hook up, Masso has a bunch of explanations for various VFDs. They said they do not have a version for the Omron VFD that is in use here. Now I could have just asked Masso and they would have told me, but I figured it can't be that hard. I'm an electrical engineer. I should know how to do this, and well, I did figure it out in the end. It took me an embarrassingly long time to get it all figured out, but it is really confusing in the kind of CNC control world. Some like an active high signal, some like an active low signal, some just want to have it pulled to ground, some want to have it pulled to 24 volts. So there's all these kind of different control schemes, and figuring out what talks to what in which way can be a bit confusing. But I managed it in the end, and I have it talking. So it's just using a 10 volt for the speed control, and it is connecting either the clockwise or counterclockwise direction pin to up to 24 volts, and that turns on the spin. Now, since I have the air-cooled version, there is also the fan here, and by default they tell you to just wire it up directly to 24 volts and just have it running all the time. But this fan is kind of loud, very loud. Now, once the spindle is running and there's other noise, it's not that noticeable anymore, and the spindle overall is still more quiet than the China one. However, if I'm just setting stuff up, jogging around, this fan is really noisy. So instead what I did, the VFD comes with a spindle on output, or at least you can configure its programmable output to be spindle on. So I'm using that spindle on output connected to a relay to only turn on the fan of the spindle when the spindle is actually on and turning, and then afterwards it turns off again. Then lastly, this spindle also comes with an RPM sensor, and that's just a very simple single wire sensor that gives 2 pulses per revolution, and I have that as well hooked up to the encoder A input of the Masso, and then I can set that it's 2 pulses per revolution. Now the Masso doesn't really do anything with that information, but you do get a display of what the actual spindle RPM is, which is always nice to see. And speaking of RPM, I don't think I've actually told you the RPM of the spindle. Now most kind of China spindles go up to 24,000 RPM. This one here goes up to 30,000 RPM. And in case you need more than that, they actually do offer higher RPM. You just kind of basically need nicer bearings if you want to go to high speeds. But this spindle at 30,000 RPMs is lots for me. And I actually ran it at 30,000 RPM, and it does get loud at 30,000. It is really quiet, kind of 24,000 and below, which is what its kind of regular speeds are. But what really impressed me, my previous spindle at 22,000 RPM out of 24, if I ran it for half an hour, it would get so hot I could burn my fingers on it, and taking out a tool out of the tool holder after it's been running for half an hour, I had to use gloves just because it got so warm. Here, running at the maximum of 30,000 RPM for half an hour, it just got kind of warm to the touch, but nothing more than that. Which, I mean, I guess is how it's supposed to be, and there's a sensor to make sure that if it got warmer, it would automatically turn off. But it's just really nice to see kind of what some proper lubrication and nice bearings can do. Now, after I had everything wired up, I tried to run the spindle, and it ran for a little while, and then I heard some weird noises, and then it didn't turn anymore, and it could no longer clamp any tools. So, well, I contacted Spinogy, and well, it was pretty obvious from the beginning that the only solution was to send the spindle back to Germany. So I boxed it up, sent it back on its way, which took a shockingly long time. The estimate was 3 to 5 business days. It took over 2 weeks. And then once Spinogy actually got it, it just took them like 2 days, and they had taken it apart, checked everything, replaced the broken part of the drawbar. Apparently, there must have been some kind of mechanical weakness in one of the bolts, or it was over-tightened or something on the internal mechanism. That's what they told me was the reason. So they replaced that, recertified everything, make sure that replaced all the O-rings that they probably didn't need to replace, but they took it apart, so they put in all new O-rings, and that of course was all warranty replacement, and then they sent the spindle back to me. And while it was only at Spinogy for less than a week, the whole process took about a month, but that is mainly the fault of the postal service and not of Spinogy. And then I mounted it back up, and everything worked perfectly flawlessly, and here it is up and running now. I will go into all of the details of kind of the logic and the function of the tool changer here in my video about the muscle controller coming next week, or if it's out already, I'll have it linked up here. So I will not go into how I set up everything here, but I'll still show you the testing that I did. And well, the first attempt was mostly successful. I fat fingered some numbers, but no harm done. I'm using 3D printed holders here for the tools, so that was easy reprint. And after that, now I have everything set up. I have the 10 tools here, both the tool setter to be able to set my tool heights, and the changing works out beautifully. So now that I have you guys set up here with a microphone, I'll just do a quick tool change just so we can kind of properly hear it, as I'm not sure if I was recording with audio and the clips before. Now, isn't that satisfying? It took me a little while to get over the pucker fracture, especially after I've had some small accidents, but just seeing it swap out the tools like a chunk, I don't know, that just gets me fired up. Now with the spindle all working, I was able to do the final couple steps before cutting, which is tramming it in. And for that, I first started by kind of roughly getting it trammed in, just using a square and just kind of making sure it's roughly squared. Then I used my big flattening bit to flatten the spoil board, and you could feel that there were some slight ridges where the kind of tools overlap, indicating that it is not perfectly trammed, which, I mean, I haven't trammed it yet, so that's what I'm expecting. But I was actually surprised on the kind of left to right tram. I got it surprisingly accurate, and it's just the kind of backwards and forwards tram that was a bit more off. Now, unfortunately, while the side-to-side tram is very easy to correct, just loosening the screws and kind of sliding it around, back and forth is a bit harder. Now, the correct way to tram that in would be to loosen the bolts here on the side for the gantry and just kind of make sure that the entire gantry is square, because if like this is leaning forwards, then that's an indication of the entire gantry leaning forwards, as everything else is just rigidly bolted together. So if you were to have it leaning forwards and you just correct the spindle, the Z-axis would now just kind of move up and down sideways. Now, the out of tramness here is very small, and I really did not feel like fiddling with everything, so instead I just added a little bit of shim stock over the top, underneath where the top bolts are. Now I ended up with a 50 micron trim here. That's not a whole lot, and that got the kind of back and forth knot in nice and straight. Then the side to side is just kind of a case of almost tightening the bolts and just kind of tapping it in. The way I'm checking for square is I put down a kind of glass sheet on my spoil board here just to kind of even out any small imperfections in the wood, and then I'm able to use a dial indicator attached to this spindle, spin it around and make sure that left and right reach the same height, and then just flip the glass around in case it is not perfectly the same thickness, and repeat the measurement just to make sure, and then that allows me to get the spindle in nice and trammed. Then, after snugking up all the bolts, I flattened the spoil board, and here we go. Now you can still feel ever so slightly some lines here indicating that it is not 100% perfectly trammed in, but it is definitely close enough, and none of that will really be noticeable. And finally, I was able to cut another guitar body. This build has drawn out a lot longer than I had planned or hoped for. Now, that's how these kind of projects go, and in the grand scheme of things, it's still pretty good. But I am at the point where all of my other builds have kind of finished, and I had a big pile of wood that was just waiting to be able to finally be processed on the CNC. So I started with this nice Purdue body here, and started ripping away. Thanks to the kind of much more beefy build of this here and this faster spindle and just general more rigidity, I was able to bump up the feet and speed quite significantly, and it is really satisfying to just see it rip and see the chips fly everywhere. And fly everywhere that did. You can probably still kind of see a bit of a red hue on basically everything around me, and that's from the very kind of orange-red color of the Purdue wood. I'm definitely building a dust shoe. It is designed, you've already seen the mechanics of it. Have not gotten all the parts in yet and have not gotten around to finishing it. But that is high time. I needed like yesterday. It makes a huge mess. That's to be expected. But apart from some minor mistakes on my part, the cutting went really nicely, and I'm very happy with the spindle's performance. I'm cutting a lot more aggressively than I was before, and the cuts are turning out nicer, and they are sounding better at the same time. And the spindle here is barely even breaking a sweat. But then the absolute cherry on top is when, it was done with the 8mm cutter and just kind of went over here, changed the tool out automatically, and dropped a whole bunch of other tools because I did not think and put the hose of the dust collector that is not working in a way that it pinched it. But no tools were harmed. After that, for the next tool change, everything went a bit more smoothly, and it is changing out the tools beautifully in the middle of the job, and that will just save me so much time of being able to set up all the tools ahead of time, touch them all off, and then the machine can just work for half an hour and I can do something else, and then come back, flip it over and machine the second side, and there we go. And with that, I think I've rambled enough for one video. If you like the spindle and you want to know more about it, please go check out Spinogy. I'm really grateful to them for helping me out getting this in here, and I could not be happier with the performance of this machine here. Now, the series is also far from over. I have the video about the muscle control coming out next week. There we'll go more into the tool changer as well. And then after that, probably a couple of weeks later, I will have an overall video about everything where I show more cutting and kind of how everything comes together. There might also be a video about the dust shoe in between there, depending on when I get the parts for that in. So with that, thank you guys for watching. Make sure to like, comment, subscribe, all that good stuff, and I'll see you next time.